When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to the past HSC exam question videos. We're going to, in this video, we're going to cover this exam question, which comes from the acid and pH scale chapter. While doing a second, I'll read the actual question. Once I've read the question, give about 5 seconds to pause the video. And once you pause the video, attempt the question and press play when you're ready again. The question itself is 0. mole per liter solution of hydrochloric acid has a pH of 1.0, whereas a 0.1 mole per liter solution of citric acid has a pH of 1.6. A. State one way in which pH can be measured, and that's worth 1 mark. B. Explain why the two solutions have different pH values, and that's worth 3 marks. So when you're ready, press play or pause and attempt the question. Welcome back. The first one is relatively simple. It's worth 1 mark, and it says state one way. So state just means name, and that all you have to do is literally just name the one way, so one way, not two, that in which pH can be measured. So I just said the pH meter or the pH counter, but you could have also said the indicators, so the universal indicator or indicators in general. So universal indicators or indicators just in general. Those would be 2 ways we can measure pH. Now that's worth 1 mark, so that's a pretty simple one. And the next one for B, what you would have done is, it says explain. So you need to just not only say why they have different, just if you mention they have different pH values, that won't get you a point because that's already given in the actual question, but you have to explain why. That's worth 3 marks. So what I do first is I go into what the pH scale actually is, or what pH actually stands for. That's obviously the minus log of the concentration of hydrogen ions. Then I go into what a strong versus weak acid is, to do with the ionization. And then I say that obviously hydrochloric acid is a strong acid and citric acid is a weaker acid. Therefore, citric acid, the same concentration, has a bigger or a larger pH. Alright, so first parts first. The pH is a measure of hydrogen ion concentration within the solution and can be calculated using pH equals minus log of the concentration of hydrogen. So yeah, what that means is that the more hydrogen concentration you have, so the more hydrogen there is in the solution, the lower the pH. So the more we have, the lower the pH. That's what this sentence gives you. And then what I wrote next is hydrochloric is a strong acid and ionizes completely into hydrogen ions and chlorine ions. So again, that's the whole idea of this equation, HCl plus H2O goes into Cl minus plus H3O plus. And because it says ionize completely, that means all of it is going to go. It's goes to completion. All of these hydrochloric acid will be, or hydrogen chloride molecules will turn into your ions. Which means that 0.1 molar, so it means that 0.1 molar solution will have a pH of 1. Because in this case we've got 0.1 molar of this, and because they completely turn into your hydrogen ions, that means we also have 0.1 molar of this. This is what we have initially, and at the end we have 0.1 molar of hydrogen or hydronium ions. And what that means is all we have to do is we have to put 0.1 mole into here, so 0.1, and when you put 0.1 into that equation, you get your pH of 1. So that's for your hydrochloric acid. That's why the hydrochloric acid has a pH of 1, because it completely ionizes into hydrogen ions. And now I'm quickly going to go into your two things popped up at the same time. The other one is citric acid is a weaker acid, which means that it does not completely ionize. It's not completely ionizing is an important part when it comes into contact with water. This also means that 0.1 molar solution of citric acid will produce a pH of higher than 1. Again, the reason for this is here we had 0.1 molar turning into 0.1 molar, But with citric acid, we would have 0.1 molar of citric acid turning into something a bit less because it doesn't completely ionize. So it might be, again, this is just not actually accurate, but let's say 0.8 molar of hydronium ions, right? So you have a slightly less hydronium or hydrogen ions because it didn't completely ionize. And if you were to type that into your pH equation, you get a pH of slightly higher than 1 because it don't completely ionize. So this would have been your 3 marks. You've gone through what the pH scale actually is. You would have said, well, the strong acids, such as hydrochloric acid, they completely ionize, which gives it a lower pH, whereas citric acid doesn't completely ionize, which means the same concentration. You could have mentioned as well, they have the same concentration. So if they have the same concentration, then the weaker acid will have a higher pH than the strong acid. And where did that come from? It came from this dot point. Describe the difference between a strong and a weak acid in terms of an equilibrium between the intact molecules and its ions. So that's what we just did. We talked about the intact molecules, which would have referred to your hydrochloric acid, and its ions referring to your chlorine and your hydronium ions. In this case, it's saying that for a strong acid, we have 0.1 molar turning into 0.1 molar, whereas for a weaker acid, we have got 0.1 molar turning into something less than 0.1 molar, thereby giving you a higher pH. I hope that was useful.
Thank you for watching.